Okay, so I guess once I stopped the other recording and started this one, yep, that's the plan right there. That's awesome. All right, so I'll just scroll through these and you can stop me at any point.
Right now I'm just trying to figure out which one they have trouble on.
Okay, so find the inverse. Got that right. Um,
Oh, on question 5, sir.
okay, sure. Domain of a radical function.
Because that's the one that you have to use.
Revenue generated by a company manufacturing lawnmowers is R equals that, where X represents the number of mowers produced. Cost to produce the mowers is C. Find the profit polynomial. And they tell you that profit equals revenue minus cost. Okay, so let's see. Did you attempt it? Should I look at your
No,
work?
not really. It's just that I had no idea where to start or where to even begin,
Okay,
to be
sure.
honest with you.
Yeah. So they want the profit polynomial. And so profit is revenue minus cost. E of X, E of X equals R of X minus C of X, which is negative 0.5 X squared plus 82X minus the cost function, which we have to put in parentheses. Sometimes people make a mistake that way by not doing that. 39X plus 400. And of course, that negative will distribute. So negative 0.5 X squared plus 82X minus 39X. The negative distributes to the 400, so minus 400, which is negative 0.5 X squared plus 43X, combining the like terms, minus 400. And that is the profit polynomial right there.
Oh wow, was that easy?
Yeah. And so now they say give the profit earned if 43 mowers are sold. And so you can, substitute 43 in here to get that. Make sense?
Yes, sir. Thank you.
You're welcome. Let's see, there was four. Okay, so you've got, okay, list the x-intercepts. One x-intercept that you didn't get was the one represented by that x right there. That tells you that 0 is also an x-intercept. Now they say write intercepts as order pairs. Okay, so 0, 0. This thing goes through the origin because of that x right there.
Oh, okay.
Yeah,
Oh,
so
yes, because it should match up with the chart. Yeah, okay.
yeah, because well, that and it's also, x minus 0. So that's another number like 3 and like negative 2. So 0 is another one.
Oh, okay. That makes more sense.
Yeah. State whether each intercept crosses or bounces. And the multiplicity of all three zeros is 1. 1,
Just because an
1.
even would bounce, right?
Well, 1 means it crosses. Okay. So multiplicity 1 means crosses. Multiplicity 2, or actually any even number, means it bounces. And multiplicity 3 had a question on this this week, means it crosses but with a wiggle. So it wiggles. Here they were all just 1, so they all just cross. The leftmost intercept, which is, well, let's see, the graph goes 0, 3, -2. So the leftmost is going to be the -2. Let's see. So you got the graph right. You got that it was D. And so, and that shows the thing going
Yeah, it's just
through.
that I messed up on the x-intercepts. That's the only thing that I did not know. So and then I just kind of guessed. Well,
I got you.
clearly.
Yeah. But you can see that it crosses for all three of them. It just crosses. No wiggle. It just goes straight through
Yeah,
the axis.
I created like a graph and it shows like the even and the odd and the degrees. So then if it's an even with a leading coefficient and with a positive degree, then that means that's going up and up. Yeah.
Well, yeah. So there's also the end behavior. So that's good. I mean, you saw that it was a negative lead coefficient and an odd degree. So that means the end behavior, which is not what's asked for, but it could help you identify the graph. The end behavior is going to be like that. Okay, so let's see what happened here. You recently started a new job. You were late for work on your first day. However, you are on time every single day after that. If you have gone to work for a total of X days, then the function p of x equals 100. X minus 1 over x gives the percentage of days that you were on time for work. Find the value of p of 50. So you got that. You substituted the 50 in for x there and there and got 98. For what values of x is p of x greater than or equal to 96? And so we're just going to take that statement and set up the inequality and solve the inequality. P of x greater than or equal to 96. P of x is 100 x minus 1 over x greater than or equal to 96. We'll clear the fraction by multiplying both sides by x times x, x, hack, hack. And what we have then is 100 x minus 1 greater than or equal to 96x, 100x, minus 100 greater than or equal to 96x. We can, let's get rid of x on one side by subtracting 96x from both sides. And we will also add 100 to both sides. And we end up at 4x greater than or equal to 100. Divide both sides by 4, and we're going to get x greater than or equal to 25. And I'm sure some people use the numerical means and maybe tech to get x greater than or equal to 25. What you could have done is the way you got the number for 50, which was 98, you could have done that for all of these on the table, 20, 25, 40, and then on the 25, it would have been for what values of x is p of x greater than 96? Okay, so yeah, you would have gotten all these, and then you would have looked for the 96 in this column, and it would have been at that.
So like you just check for each and every single one of them?
Yeah, I mean, that would be another way to do it. What you could do, it would have been legal to put this function in your calculator. And if you, would like, we can look at that. And then, get the table, which actually you'd have to know how to deal with the parameters for the table.
Yeah, I was about to say, I don't know how to really plug in the inequality into
Sure,
the
let's look at that.
calculator.
Okay,
Can you help me with that?
Yeah, absolutely. So you have a TI graphing calculator?
Yes, sir.
Okay, so let's put P of X in here, 100 times X minus 1 in parentheses divided by X. The table is probably just going to be the X values are, they're just the integers. Second graph is table. Okay. Oh, I've got it set to half. So I'm going to change my parameters here. And normally what we have is, okay, so I'm going to go, Jacqueline, to table set, which is second window. Second window is table set. Normally this is 1. The delta table is 1, which means you just have X going through the integers, -1, 0, 1, 2, 3. I had it set at a half, but I think we're actually going to want it to be set at 5 because our X values, at least the ones we're interested in, they're like 5 or more apart. So I'm going to set the delta table at 5. And let's look at that table. Okay, so, but we don't have multiples of 5. So I have to change my table start to a multiple of 5. I'll just put it at 0. Second graph is table. Okay. So we get these values, some of which, are suggestions from the problem. For 20, it's 95. So it's not quite what we're looking for in number 2 there, because it says p of x greater than or equal to 96. So that's not going to include the x equals 20. But then for 25, we do get to 96. And it's 96 exactly. So that makes us think, oh, that's actually just going to be the answer here. It starts at 25 and goes up from there. 40 is 97.5, 97.5. 50 is 98. 100 is going to be 99. And 200, I believe, is 99.5. Hundred is 99. Two hundred is 99.5. Now, what if you're going to use tech to answer this question? What you really should do is reproduce the table that you're seeing in your on your calculator screen. Just for anyone who would be watching this, it's not, you never just put the answer. You always do a sketch of what's on your calculator screen, or you show algebra, or you show work, or you explain your reasoning. We always support our answers. This is college. So it starts at 25 and goes up. Basically, this is the inequality here. Makes sense, Jacqueline?
Yes, sir. It does make sense. Thank you for the calculator tip. I did not know that.
You're welcome. My pleasure. Yeah, there's that when you're taking a math class, you're learning the math, but you're also learning your calculator. Can p of x ever be exactly 100? No, it can't ever be exactly 100, because this ratio here is always, it can never be 1. It's always going to be less than 1, because the numerator is always going to be less than the denominator. And because this ratio never does get up to 1, 100 times it never is going to get up to 100. So let's see, which one is that? No, because the value of p of x will always be less than 100 as x becomes very large. That's true. That could be a good answer. No, because 100 is not in the domain of p. But actually it is in the domain of p. There it is right there. And there's a perfectly good output, 99 for it. So the answer is the first one here, because as I was explaining, this thing, even when x gets very large, it's still not going to be 100. Okay, question 7. Let's see. It's 2.5. You put 2.48. I'm thinking that is going to be credit for you, because I'm looking at the work here, and you are just doing what you're supposed to do there, which is just substitute the number in.
Yeah, I was just about to say sorry for like it doesn't look very good right in that lighting, but I did try. I did substitute it. Yeah, I would say you could see
Yeah.
that I did substitute it. It's just that I didn't know how many integers can I round up to, so then I just put, usually it's usually 2, so then I just put 2.
Yeah. Well, let's see who we have here. No, there's not an ALA. We're just debriefing the test. Okay, so you're good on that.
But was the other one correct, sir? The bottom one, the 12.94?
If it takes, 4 seconds for a pendulum to swing back and forth one time. Determine the length of the pendulum. You put, oh, the answer is 13. Oh, and you were more, okay, so you had better accuracy than that. So that's probably going to be full credit also, because you solve for x, you let s be, s of x be 4, and then you solve for x. I think I saw that. Four divided by 2 divided by pi square multiplied by 32. Yeah, the algebra's there. Yeah, your answer is probably more specific, more accurate than the other one. So great job there. A question came in about these why is the sky blue things, and the guy was afraid that they really were real questions. At first he thought they weren't real questions, but then he became afraid that they were real questions, but they're not real questions. They're just placeholders because we're not quizzing on learning target 8 yet.
Yeah, I did see that the fact that in the practices, not all of the practices were on there. I did see that A and specific numbers weren't on there correctly.
Right. Yeah, we're not quizzing on learning target 9 or learning target 13 or learning target 14 or learning target 18 yet. But the other 15 we are quizzing on test 2. Find the zeros, including complex zeros. Okay, so this is good. I'm glad this came up. We're going to have to do this, and I'm not sure if we've done this kind of thing in a meeting in this class, top to bottom. So it would be good to talk about this. Now let's see what you actually have.
Yeah, I was gonna say I remember.
Okay, so that's good. You did do division in the problem, which is required. And okay, so that's actually pretty good. Let's see. You use the rational zeros theorem, which you actually don't have to do, but apparently you were able to use that. I'm impressed by this because you were able to use the rational zeros theorem to find a zero which was -1, which you show algebraically by doing the synthetic division. Now that you have that factor, you're going to use the depressed polynomial, which is x to the third plus x squared minus 10, let's see, degree 4, degree 3, degree 2, degree 1, degree 0. X to the third plus x minus 10. Okay. Oh, okay. So yeah, and then factoring that, yeah, that's a problem because, yeah, that would actually take miraculous factoring to do that.
Yeah, I was gonna say that's the one thing that I did get confused on. Yeah.
Yeah, so you've done part of it for us. You got a 0 of -1. Let me just confirm that your synthetic is correct, which I'm sure it is. 1, -1, 0, 0. Okay, so -1 is a 0. And we're going to use
Yes,
that.
I also double checked on the calculator. So and then I did like see the fact that one of the x-intercepts was -1. So I didn't try to figure it out on there, but I just didn't get them all.
Great, great, great. So for someone, who's just coming into this and doesn't have a clue about this, Jacqueline showed, kind of the traditional way to get that first zero, and that's by using the rational zeros theorem, the P's and the Q's and the P over Q's. Now, you do the synthetic the way she did, and well, I'm just going to run it again. Okay, so -1 and 1, 1, 1, -9, -10. Bring down the first thing, multiply and add, multiply and add, multiply and add, multiply and add. Okay, now this is third degree, this depressed polynomial. So, it's not like we could go right to quadratic formula or even factoring, because that would require miraculous factoring, because x cubed plus x minus 10 is a higher degree polynomial with a non-zero coefficient or a non-zero constant of -10. And I've made it clear that in the instructions that that sort of factoring is not allowed, because I've been teaching long enough to know that students generally just can't do that kind of factoring. I've, been in classes with, young people and talked about, factoring this and saw all the blank stares. So, if someone comes up with a factoring, I call it miraculous factoring, wink, wink. But what we're going to do is use tech then to try to get a second zero, because if we can get the thing down to a depressed polynomial, which is second degree, then we can go to the quadratic formula. So I'm going to input all of this. Let's place for this guy. And I think I'm going to mess with my table set also, but let's see. X to the fourth plus x cubed plus x squared minus 9x minus 10. And let's see, we've got the table. Yeah, we need to mess with that. So, because we want, at worst, we want integers. We might even want a smaller delta table than 1. So we'll start it at -1, and we'll see the 0 there, and do the regular delta table of 1. Give me that table. So there's the 0 at -1. We also see 1 at 2. So we're like, okay, 2. And of course, that, no doubt is on your list of rational zeros, because if it's a 0 and it's a rational number, then it's going to be one of these P over Q's. Yeah, and there's the 2, which tech is indicating is likely 0. Now we don't just take it as gospel because it is tech. This is a math class, so we're going to confirm it algebraically. So I'm going to stack the synthetic. By the way, what we're doing here is also, it's even more applicable to learning target 16, which is going to be number 16 on all the quizzes. This kind of finding all the zeros. Okay, so let's see. Bring down the first thing, multiply and add, multiply and add, multiply and add, and yeah, that's a 0. So the zeros, -1, we got the 2. The 1, I don't believe is a 0 from the table. The table, I don't think, showed a 0 for x equals 1. But we can get the other 2 by just taking the really depressed polynomial, x squared plus 2x plus 5, and getting the zeros of it, and zeros of it will be zeros of f. We'll use the quadratic formula with a equal to 1, b equal to 2, and c equal to 5. Then x equals minus b plus or minus square root b squared minus 4 a c all over 2a. Now we can tell by looking at this thing under the radical. This thing under the radical, by looking at that and seeing that it's going to be negative, it's called the discriminant for that reason. It helps us discriminate between different kinds of quadratic equations. We can tell from that these are not going to be real zeros. They're going to be non-real complex zeros, which is kind of, what they're hinting is on its way when they say including complex zeros. So we'll just grind through this quadratic formula to get these 2 non-real complex zeros. -2 plus or minus square root 4 minus 20 all over 2, which is -2 plus or minus square root -16 all over 2, which is -2 plus or minus square root of 16i all over 2. Negative comes out as I on the outside, which is -2 over 2. I'm going to split this this fraction apart horizontally. So I'm going to split it apart so that we put the 2 under each, add end. Plus or minus, and then put the 2 under the other thing, which is just 4i. So -1 plus or minus 2i. Those are the last 2 zeros. So the 4 zeros then are, and we know there are 4 because it's 4th degree, 4 complex zeros. So the 4 zeros are -1, 2, -1 plus 2i, -1 minus 2i. Make sense, Jacqueline?
Yes, but I have a question though. How can you tell when you can use the quadratic or when can you use the factoring for the polynomial?
Okay, well, if it's Oh, you mean just the rules or for like a problem like this?
Just the rules.
Oh, okay, okay. So let's go back and look at the instructions. Um, let's see here. And so I'm going to explain what I'm saying here, which is involves kind of some, I mean, I tried to get the math jargon out of it, but you do need words to describe things. So let's see. Um, let's just do this. Okay, so for number 10 and number 16, no factoring of third degree or higher polynomials. Now the third degree part, that's easy, right, Jacqueline? We just had a fourth degree, so we know that's, you know, included in this. With non-zero constant is to be done, some kind of division will have to happen. So in this problem, we know that you just couldn't use factoring for the whole thing. Now, doesn't mean that it when you could use factoring when you've reduced the fourth degree to a second degree. But so it's kind of like two things. Um, third degree or higher, and then non-zero constant. If both of those things are present, then don't use factoring. Okay, we've got fourth degree right here, fourth degree, and there's a non-zero constant. Okay, and so that means no factoring. Now, on what we did, when it became second degree and we went to quadratic formula, now it's less than third degree, and factoring is allowed. So does that kind of make sense on when factoring is allowed and when it's not allowed?
Yes, no, that does make sense. It's just that I always get confused with that, specifically about the constant zero. That's the one thing that I did
Oh, I
not
got you.
know in the text.
Yeah. Because if you had, if you had a third degree, if you had a third degree, see, I have to be specific like that because there are problems where you have a third degree and without a non-zero constant, and it would be factoring would be allowed um, because you could just factor out one you could just factor x out of it, and then the result would be second degree, which it's allowed to it would be allowed to factor that. So number 10 and a half, if you had find zeros, I'm just making up a problem now of, and I don't even, well, I could figure it out. So let's say g of x equals x to the third um, minus 6x squared um, minus 8x. Actually, in my example, I'm going to change this to 2. Yeah. Okay, so then you could say factor out an x factor this little second degree trinomial, but that's not miraculous factoring. That's just regular factoring. Okay, so I'm not going to, worry about that. And then you would get the 0 and the 4 and the -2 out of it. So that would be okay. And it's the absence of that non-zero constant over here that made it factorable legally. If you throw a +5 over there or just some other constant, then if the factor becomes miraculous because you just can't factor, some simple little trinomial like that. Right, Jacqueline?
Oh, okay. No, that does make some more sense, sir. Thank you.
Yeah, you're welcome. I'm glad you asked because yes, one of the zeros is the origin. Or we would say 0 is a 0. Yes. But not a number 10. I'm glad you asked about that because, the instructions, I, you know, you write something like this and you're just hoping that it registers with students, but, a lot of times it doesn't. Okay, so we've got this work problem,
Yeah, I also did not get that one either.
application of
Yeah,
rational.
the applications questions were the most difficult for me.
Yeah, yeah, because there's an extra, layer there where you have to, oh, they give you a table. I might actually use the table. It's not required, but let's see here. One pump can empty a pool in 6 days, whereas a second pump can empty the pool in 14 days. How long will it take the two pumps working together to empty the pool? So this is of the general species of working together problem. Okay. You could have, another example would be like, Alice can mow the lawn in 2 hours and Bob can mow the lawn in 3 hours. How long would it take them together working together to mow the lawn? Now, when the question is how long will it take them both working together, that answer has to be less than the lower number. It has to be less than 6 here because if one pump can do the job by itself in 6 days, it's only going to be less than that if that pump has help. So we know this answer is going to be less than 6. So time alone for pump 1 is 6. And for pump 2 is 14. The rate alone is going to be 1 pool per 6 days. And for pump 2, the rate is 1 pool per 14 days. Okay. Now let's see. They say time together, work together, number of jobs. Okay, so number of jobs, is 1. And time together, that's what's not known. Okay, so time together, I guess would have to be on this row. Number of jobs, I don't get their table. Okay, so let's forget that. I thought that was going to make more sense. Maybe I'm just missing it or something, but I think what it's trying to do is something like this. you, we're going to set up an equation which is the part of the job done in 1 day by pump one. Okay, so part of job done in 1 day by pump one plus, Jacqueline, would you read to me that what's in that chat if it's for everyone?
I'm sorry, can you repeat the question?
Well, Marian is putting something in the chat, and if you can see that, if you would read it to me, that would be great. Are you able to see that, or is it just?
Oh, yeah, it says that once you have to multiply the rates or divide it or something like that.
Well, you're going to add the rates, really, is what you're doing. Part of the job done in 1 day by pump one plus the part of the job done in 1 day by pump two equals the part of the job done in 1 day for their working together. Part of the job done 1 day by their working together. Okay. The part of the job done in 1 day, what does he say now, Jacqueline?
For me, it doesn't say anything, sir.
Okay. Okay. So part of the job done in 1 day by pump one is 1/6. Pump one can do 1/6 of the job in 1 day because it takes the pump one 6 days to do the whole job. And pump two in 1 day can do 1/14 of the job. We're going to call X the answer to the question. How long will it take the two pumps working together to empty the pool? So all of this is how we define X. X. And so then the part of the job done in 1 day by their working together is 1/X. If together they can do the job in X days, then working together, they can do 1/X of the job in 1 day. Oh, yeah. No, we just add their rates, and that's the together rate. Solve the rational equation, multiply both sides by the LCD. The LCD is, let's see, what's the least thing that all three of these go into? 14, 28, 42x. 42x. Okay. So multiply both sides by 42x. 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 And Jacqueline, can you see how we have 7x plus 3x equals 42. Are you okay with that equation?
Yes or no, I think that's good.
So 10x then equals 42. We can have 4.2 for x.
So and then it'd take 4.2 days to empty the pool together.
Yes. A number less than 6 Okay, so let me just grab a shot of this and we'll move on. Are you good, Omarion, with that?
He's not here, sir,
Oh,
anymore.
okay, thank you. Thank you. Solve that equation. Okay, so let's see. You got that x does not exist here, but there is a value of x that does work. So is there algebra here that went wrong, or
I believe I did do algebra,
okay,
but it's
so
just that I didn't think I don't know why I did get an answer. I just don't know why I didn't put it. And also I thought it didn't exist because of the negative, but I don't know.
yeah, well, I mean, you want to check it for sure, um, because you do get what we call extraneous solutions. And so you always have to check your answers to radical equations. Well, let's see. You squared both sides. That looks good. Negative x minus 3 equals 36. Add 3 to both sides. Oh, that's where it
Oh,
went
that's where I messed
wrong.
up. Yeah,
You
there's
did it.
39. Oh no.
Oh, you did everything right except 36 plus 3. Oh, that's frustrating.
That's a bummer. It's
Yeah,
fine.
that's it. You might get credit for that. I'll have to think about it. I mean, that might demonstrate mastery because it's just a little arithmetic thing. It's not about the answer. It's 99% about the work. 15. Um, I'll make a comment. Let's see.
Yeah, I was about to say, I think the only thing that I messed up was the fact that I realized this after the test that the intercept of -2, then it would just go down to integers, no?
Yeah. Well, let's see. No, the graph. So you're talking about the graph then.
Yes, sir. Yeah, I'm talking
Okay,
about the
so
graph.
why is that wrong? Let's see. X-intercept. Oh, okay. Well, your x-intercept, which is 1, 0, and that was what my comment is about, is that I don't know if this applies to you, Jacqueline, but a lot of people don't even show work on that. But you have to show work on finding the x-intercept. You have to set y equal to 0 and solve for x, right? Why is that a no worker? That takes algebra. So
I was
Add
about to say,
two.
I think I did fill my work, sir.
Okay, yeah.
For that
Well,
problem.
yeah, I was just commenting for everyone. I didn't know about you, but just for everyone else's sake, because people do think for whatever reason, I've graded enough of these that for some reason that doesn't take work, but it does take work. So two equals square root x plus 3 and square both sides. I guess it looks like it feels like there's a rhythm going to happen there with a bunch of no workers. So people just see that 1 0 from tech and then just put it down. But track 3 x equals 1. But on your graph, Jacqueline, it's not, that point isn't on the graph, right? That point right there should be on the graph. But you've got the graph going through the origin.
Oh, okay, that makes more sense. Oh, okay.
The this number here is approximately negative 28, I'm sorry, 268, negative 0.268. So that's going to come in right below the origin. And as we said, 1 0 is there. Domain, it does start at -3, but yeah, basically when you used the square root graphing tool, you wanted to probably use that 1 0 instead of 0 0.
Yeah, that's the only thing that confused me was the y-intercepts, which is why I didn't put. I don't know. I don't even know why I didn't put the x-intercept, but it's fine.
Yeah, the y-intercept, I mean, most people are going to go to the calculator, and just get a value of square root of 3 minus 2. Square root of 3 minus 2. And that's how you know where to put the point. Now, you might have, do you remember, had you mastered Learning Target 15 before? Did you pass quiz 15 before?
I believe I did. I don't really remember though.
Okay, so I mean, it's not, probably doesn't matter that you didn't get the graph right because you probably already had credit for quiz 15. Consider the function, use your graphing calculator. See, now this directs you to use the tech to get a 0. And you did that. And so it's kind of thinking like I am about it, which is, do we really need, in 98% of cases, we don't even need the rational zeros theorem, the P's and the Q's and the P over Q's. Okay, so you used tech and you used either the graph or the table to get -4 or a 0. And it's third degree. You certainly, I know you didn't do this, Jacqueline, but, I'm sure I'm going to get people that are going to try to factor that thing or claim to factor it. And what you're really supposed to do is division. So -4, we're going to get a second degree depressed polynomial. So 5, 15, -13, 28. writing down the first thing, multiply and add, multiply and add, multiply and add. We confirm that that's a zero because we got a zero remainder. And then we're going to go quadratic formula on that. And, well, I'm just going to look at your work and see what went wrong with that.
Yeah, I was about to say I was just double checking right now because I did do synthetic division also. I did get that. It's just that I think the factoring of the after of the synthetic division is what messed me up.
Right, right.
It's on the second page, sir, of that PDF, I think.
Right, right. Okay, so you went ahead and did the rational zeros theorem, even though you didn't have to. So that's fine. No problem. Okay, so let's see what happened. I'm sure that's the same depressed polynomial that I got. Yep. Minus b squared. Okay, so it's kind of hard to see where things went wrong there. Um, but it would have been minus b plus or minus square root b squared minus 4a 3 all over 2a, which is 5 plus or minus square root 25 minus 140 all over 10. And that's where the problem was. You saw you added somehow you had an issue with the sign.
Sir, where did you get the 25 from? May I ask?
B squared. So that's always positive right there. The b squared. So
Okay, okay, yeah. So
okay,
then it's 5 squared. Yeah, oh, okay.
that's what it was. You put negative 25 right there, but that can't be negative. That's always positive because it's a square of something real. So that's how you got the 165 when that's really negative 115. Y-intercept, okay. The fraction is kind of preferred there, but they counted it as right. But negative 1/3 would be better. X-intercept, okay, you got negative 1, which evidently is 1 of 2. The other one is 5/2.
So for that one, would it be the factored form of the denominator or for the numerator, sir?
It's the numerator because what you're doing to get x-intercepts is you're setting y equal to 0, solve for x, right? That's how we always find x-intercepts, is set y, which is f of x, equal to 0 and solving for x. Now, when you're going to solve that equation, you have to think, okay, how do we solve, how do we get zero? How do we get zero out of all this stuff over here on the right? How do we make all of that zero? Well, we make the top zero and the bottom non-zero. So what the algebra reduces to is just setting the top equal to zero. And so you just solve the quadratic equation. Apparently, this can be solved by factoring 5/2. Okay. So apparently the factorization is reverse engineering. What you would have gotten was 0 equals, if you factored it, it would have been 2x minus 5, x minus 1. And then, you would have gotten the 5/2 or 1 for your x-intercepts, right, Jacqueline? Does that make
Yes.
sense? Now, the vertical asymptotes come from zeros at the bottom, and it is important to factor top and bottom. You have to know whether it's possible to do any canceling. If you can do canceling,
And doesn't that mean that there's a hole or something like that?
right. If you can do canceling, then there's going to be a hole. Now let's see, f of x is 2x minus 5, x minus 1 over, let's see, work. Negative 5. Apparently that is the factors that, no. Oh, it's plus. Let's see. 2x squared plus 5. Yeah. Okay, apparently that's the factorization of f of x. You can see that nothing cancels, even though they give you a head fake and they, are hoping that you're going to try to cancel those two things. But they are not same thing, so you can't cancel them. And so there is no hole, and the vertical asymptotes come from zeros at the bottom. You got the -3, but there's also a -5/2. Does that make sense?
Yes, sir, that does make sense. I did know that you have to factor it. It's just that I could not factor it completely up all the way.
You could do that the same way with go to tech, and you're going to get a 0 of -3 from the tech. No reason why you couldn't do that on a quadratic, because that is not the easiest thing to factor. So I love that tech hack on factoring, which is such a pain. And, this goes back to pre-COVID, face-to-face experiences. 2x squared, 2x squared plus 11x plus 3. And you go to the table and you get that 0 at 3. So the x minus 3. But we did that factorization. Let's see. Oh, it's 15. 15. Of course, to use the tech hack on factoring, you've got to input the expression correctly. -3. Okay. And so that tells you that one of the factors is x plus 3. And then if you know that, it's kind of easy to get the other one, because you could either do the synthetic. That's probably the easiest way. I should leave it at that. -3 from tech is one of the factors, and so, or that x plus 3 is one of the factors. And then you could use the synthetic to get 2x plus 5 as your depressed polynomial. Horizontal asymptote. Now this is a problem that can be done mentally. And basically what you note on this is that the degree of the top is 2. The degree of the top is 2, which is this 2 right here in the exponent. And the degree of the bottom is also 2. These two things are the same. They're both 2. Same. And if it's same, then the horizontal asymptote is the line y equals the ratio of the leading
Of the leading coefficient, so then it'd be 1. Oh, I did figure out about the rules of the race to infinity, I believe. Those are the rules.
Yes, but that's not how you want to think of it in college algebra. Y equals 2 over 2. Y equals 1 is the equation of the horizontal asymptote. The way you want to think about it is that there are 3 cases. Same, less than, or greater than. If it's a less than, then the answer to the horizontal asymptote question is y equals 0. And if it's a greater than, then the answer to the horizontal asymptote question is there is no horizontal asymptote. So this question here, horizontal asymptote, that is a question that you answer mentally. That's really what you should do. And I am not going to require work on that. What I really was warning against in the syllabus, so that one right there is mental. what you really don't want to do, it's going to, be just bad all around, is if you try to bring in calculus. Because I'm going to think you got that from somewhere where you shouldn't have gotten it. It's not calculus, it's a problem you do mentally. Okay, well, we're out of time. I'm just going to peek at the rest of this. Great participation. I don't want to just end this if there's one burning question out there. 19 will depend on, your work, but it is good that you got the right answer. But then in 20, you didn't get the right answer. But basically, the key thing is I want to see test points. Not a bunch of algebra, not a bunch of inequalities.
Yeah, the only thing that I was confused on was the x minus 5 squared, because that kind of threw me off, since I remember that I didn't know if the x minus 5 would mean two integers, if it would mean -5 and 5, or if it was just 5 by itself.
Um, okay, so number 19, that looks good because um, in fact, both of them, you've got test points. So happy to see that. Now, to check whether the interval, say, on the right is an interval of solutions, you will use the test point, say 6, which is the one you picked, and you put it in there for x and just see if you get the truth. So 6 and 6, and is it true that 6 minus 4, square of 6 minus 5, is that greater than 0? Question mark. Well, it is greater than 0. It is a yes there. You put it true there. So maybe it was the middle interval that we fell off the wagon. But then, you do as much of the arithmetic as you have to tell whether you've got the truth there. What is going on in the chat up there? Okay, so let's see. This is 2 times just 1, right? 1 squared. And then 2 times 1 greater than 0. 2 is greater than 0. You got true. So that's how you deal with that squaring, right? Jacqueline?
Yes, sir. Yeah, I did get that answer. It's just I don't know where I messed up.
Okay.
That's the one thing that I'm trying to figure out right now.
It's probably the middle interval. Let's see, 4.5. Yeah, in the middle, you've got a 4.5. Four point five, 4.5, and that's going to give you a false, because the first factor is oh, actually, That is a truth. I don't know why you didn't get the right answer there. All of that's true. That's positive. That's a positive times the square of a negative. So negative 0.5, but when you square it, it comes out positive. So that's going to be 0.5. That's going to be 0.25. But you're multiplying two positives, so that's going to be positive. So you do get true in the middle, and let's see on the right. Oh, that's the negative. That's the false. Because if you let x be 0, if you let x be 0, then it goes like
Oh, then the first would be a negative and a
yeah,
negative times. Oh, okay, I see. No, I see where I messed up. Oh, okay.
yeah. Oh, the test points are these numbers that she's using, which are 0 and 4.5 and 6. The critical numbers are 4 and 5. So she picked three other numbers, one to the left of 4, one in between 4 and 5, and one to the right of 5. Those are the test points. And that's how you have to, x can't be less than 4, he says. But that's how you have to determine which are the winning intervals. Yeah, x can be less than 4. That's how you determine which are the winning intervals that are part of the solution set by picking other numbers, not the critical numbers like 4 and 5, but other numbers like 0 and 4.5 and 6. All right. Well, appreciate the input, people. Have a great night, and looking forward to more interaction with y'all.
Thank you, sir. Thank you for the help for my test. I really
My
appreciate it.
pleasure. My pleasure. Take care.